So you've made it to step 4, and your instance tree is populated. It is time to check and resolve any tooth tip intersections. First, you must set your trim accuracy. This defines the size of the rotational increments at which the intersections are checked. Fast means a high increment is used, which is good for quick experimenting within the software. Standard is more accurate and recommended if you are planning to export and manufacture your design. Slow is even more accurate, but will take a while and may be more accuracy than you need. I will choose Standard for this example. To start, click Begin Trim. The gears will be rolled together and tooth peaks shortened where intersections occur. Typically, peaks collide against valleys, in which case the peaks yield. Sometimes, peaks collide against other peaks, in which case the taller tooth yields. Note you can adjust the trim accuracy even as the trim is in progress, but the accuracy will only apply from that moment forward. Only the first symmetry lobe must be trimmed, as the remaining lobes will copy its result. If your input gear has a radial symmetry of 3, for instance, it will only need to complete 1/3 of a rotation while trimming. The exception to this is if one or more gears use a non-zero backlash, in which case 2 passes are made, one for forward engagement and the other for backward engagement. When your trim is finished, you can proceed to the final step of exporting your gears.